I was muted. None of them said why. Hmm? Okay. You should say, guys. Okay, I don't know. Accident. I thought I didn't mute. Here, when I use the annotation, that mute part will disappear. Okay. And Mahdi also asked me, right? School precises me to put like this. Yeah, actually, this is Sir wants to do. I replied for that also. Okay, guys, so this was happened, right? So the delta G is equals to, this is your equation, delta H minus temperature into entropy, change in the entropy. Now we are going to substitute the answer. Whenever you substitute the answer, they have given what, the minus 26.0 kilojoule mole minus 1. Why this 0? Why can't you write like this? Yes, you couldn't write like this when you are substituting the value. This along with the unit is very important. And whatever the value they have given, that is what you have to use. You can't use this value. Why? Either is 26.3 means you will substitute, right? So they have measured up to the decimal point. So whatever the value in given way, you have to substitute. Otherwise, they will deduct marks. Right. And once you substitute, what you want to do is you have to find the delta H. So here, okay, you know, delta has become here. Again, the 26 will become the positive. So ultimately, I have found the answer for the delta H. Are you all clear? Guys, if I'm muted, please
Yes,
definitely
madam.
say guys, right? Don't be silent. Okay, I was writing something, right? You should say. Okay. So the next question. Would you expect the solubility of the MX to increase or decrease with the increase in temperature? They are talking about the solubility of MX. When you increase the temperature,
Madam,
again your connection got poor. The solubility of the MX, whether increase or decrease when you increase the temperature. Do you have any answers? Anyone?
that's not clear, madam. What?
Give me a second. Yes. The question is the solubility of the MX, though it is increase or decrease when you increase the temperature. Simply, if you increase the temperature, what will happen for the solubility of the X? That is the question. If it is increase or decrease, you have to give the reason. That's all. Any idea? Any
It will
idea?
increase.
The solubility is increased.
Madam.
Why? Why? Yeah, that will be increased. Yeah, the answer is correct. So what should be?
Because
Again, Abdullah, your line went upset. Okay, so what is definitely happening here is the temperature is increasing. When you increase the solubility of MX is increasing when you increase the temperature. Simply you can say is, if you increase the temperature, the system is absorbing energy, therefore your solubility also increasing. The dissolution of the MX is increasing. That is one thing. Another thing you can say, if you increase the temperature, right, the delta G become more negative. More negative what? It more feasible to the reaction, it become more spontaneous. So spontaneous means what? the solubility of the MX should be increased, then only that reaction will be feasible. So the answer is it will be increased. Why? When you increase the temperature, the dissolution of the MX in water also will be increased. As per your delta G become more negative, will reach to the spontaneous reaction. Or simply you can say the MX is an endothermic reaction. Dissolution of the MX is an endothermic reaction. What it's doing is it's absorbing the temperature and it dissolves or it's soluble quickly. So the answer is it will be increased. Right? Okay. We have completed the question number 3 under 2019 paper. Wait, I will share the next question. You can see the paper, right? Question number 6. Let me do this question.
Yeah.
Yes. Can you see the question? Okay, I can see you. Clear all thing, right? Guys, can you do this question? Question number 60. I need answer. Please don't check the question. Answer. I need the work. Please find the answer and you have to explain how you perform the answer. I will give you 5 to 7 minutes. Can you finish it? At least read the question and try it. I just explain you all, right? The enthalpy change of the vaporization and the enthalpy change of the vaporization of a liquid is given, right? The boiling point of the liquid is. Now you can do. You have to find the boiling point. You have the enthalpy and entropy. What should be the equation? Just think and do. Very simple equation, simple question. Right? The time starts now. You can think. I will search the next question and come. Okay, found the answer? Very simple question. The enthalpy change of the vaporization and the entropy change. Wait, and I mute. It's given. Right. I will stop sharing and we'll go for the whiteboard. Okay. The question is, yes. So none of them find the answer. So what is the question? The enthalpy change of the vaporization of one liquid. Yes. You found the answer. Okay, I'll do the question. So enthalpy change delta H is equal to give me a second, guys. I'll be back. Just give me a second. Sorry guys. Yes. So the delta H is equals to, the value is given, that is 45.00 kilojoule mole. Delta is also given 90.0 joule Kelvin minus 1 mole minus 1. Right? And you have to find the boiling point. The boiling point means what? Indirectly you have to find the temperature. That is the question. Right? So you able to understand the question. This is what the process of the vaporization. So what should be the delta T? Yes? Any idea? So they ask what is your boiling point? During this vaporization, at the boiling point, the delta G is 0.
Madam, how do you say that?
The process is at equilibrium. I said if your reaction is reversible or equilibrium, you can say delta G is equals to 0. I said right? Just now.
Madam, how do you know it is reversible?
So boiling point, right? The process, what is happening? The vaporization, liquid to the transformation.
Then whenever they say vaporization, Gibbs free 0. Always.
Vaporization, liquefaction, at any step, it has equilibrium, reversible reaction. Transformation, phase transformation, one phase to another phase. It will make an equilibrium. This is what you are studying in your what? Phase diagram. This is what you have studied in your phase diagram. This should be vapor, this should be liquid, and this is what the boundary. In between this you will see what the equilibrium. This is what the phase transformation. So thus is the reaction is a reversible equilibrium. The delta G is 0. At the boiling point you can say that is the delta G is equals to 0. The equation is delta G is equals to delta H minus T into delta S. So as you know the delta G is equals to 0. For delta H I am substituting 0 kilojoule mole minus 1 and minus T into 90.0 joule Kelvin minus 1 mole minus 1. The temperature is equals to your boiling point 45.0 kilojoule mole minus 1. It should be divided by 90.0. Am I correct? Is it correct? Did I miss anything? You have to find it. Did I miss anything? Have you seen? This is a kilojoule. This is just a mole. So what you want to do is, you have to convert into the joule. Should multiply by 1000. Now your answer is. Your answer is yes. 227 degrees Celsius. 500 Kelvin. Do I need to rewrite up? Can you all see? Is it visible? Did you all understand? Is it clear?
Yes, madam.
Right? Okay, so you will end up with what? So simply you can say, right, by using that equation, delta G is equals to delta H minus T into delta S. So therefore you have need the temperature, though you say this is a 0. This is what? It's a delta H minus into delta S. We are going to find the boiling point, that is the temperature. So that means your T is equal to delta H divided by delta S. Here the unit, I'm just going to speak about the unit, that is kilojoule mole minus 1, and your entropy unit is joule Kelvin minus 1 mole minus 1. The mole will cut off. We have to end up with what the Kelvin, why the value is given in Kelvin. And this is joule, this is kilojoule, so I have to convert into the joule. So now, this is also good. So joule will cut off. This K will come up. So your temperature will come in Kelvin. That is the 500 Kelvin. But your answer is given in what? Celsius. So what you want to do is you have to deduct 273. And you will end up with the answer is 77 degrees Celsius. Are you all clear? Is it clear? Okay. So actually another 10 minutes more, right? We have the session at 8 minutes. As we finish this session 8 minutes, within 8 minutes. So we will meet on tomorrow, right? If suddenly drop out, we'll see. Okay, what should be your next question? Structure. Sharing. Question. I have found the question. Yes. Question number 26. Okay, I'll do the question. We have just 18 minutes. Okay. Which of the following reaction step is not present in Born-Haber cycle of the formation of NaCl? So you know the Born-Haber cycle, right? How the NaCl going to be formed? So what you want to do is first let me write the Born-Haber cycle, right? Okay, the question is with you, right? I will stop share and I'll share the board, clear board, and I'm just going to do the Born-Haber cycle. What was the question? Is the formation of the NaCl. Formation of NaCl. So what should be the first step? Yes, Na solid, Cl2 gas will give NaCl solid. Born-Haber cycle. I'm talking about the Born-Haber cycle. Here, the delta H, the formation of NaCl, should be always 1 mole. So I'm just multiplying by half. Now you have to reach to what? The NaCl solid. What should be the first step? Yes, here the Na should convert into Na plus, right? Sorry. First Na gas vaporizes sublimation from S2 gas. Then it should convert into what? Ion. First ionization energy. This is, you can say, delta H sublimation, delta H E1 first ionization. Next, this atom chlorine should become as a chlorine gas. You can say this is delta H atomization, and this Cl should become Cl minus gas. That is what? Electron gain energy each one. When this Na plus Cl minus form together and forming NaCl, we are telling this is as lattice energy, the formation of the lattice energy, right? From what is the equation for the lattice energy? If you want to form a solid NaCl, that should be formed from what? The ionic formation at the gaseous state of the each atom, right? Okay. So now let's check the answer one by one, right? You have this diagram. Just give me your answer. The first answer is, I will just write the answer and raise whether it is correct or not. Good morning. Just wait a minute. Okay. Right. So one. First answer. Na plus aqueous Cl minus aqueous, which will give NaCl. That is the first answer. Let's see, write the second answer. Right? Cl2 gas becoming 2Cl gas. That is the second answer. What should be the third? Sorry, this is the third. Yes, this is the third. After this. Na solid becoming as a Na gas. That is your second question, second answer. So Cl gas gaining electrons and becoming as a Cl minus gas. And your fifth one is Na plus Cl minus will become NaCl. What should be the answer? Yes? Anyone? What should be the answer? So look at this diagram, right? I will redo this question again tomorrow. Whenever they ask you to construct the Born-Haber cycle, the formation of the NaCl, first you have to understand how to draw the sodium chloride, right? So the sodium chloride means what? Okay, guys? Okay. So that should be the solid formation. So even whenever any form of the molecule formation that will origin from the state how it appear in your atmosphere. The chlorine always a gas, the solid is sodium is a solid. Now what you want to do is you have to convert into gas, then again the ion. And here atomization and the electron ion gain energy. Finally you will face what? NaCl. This is what the Born-Haber cycle. What the Born-Haber cycle, he spoke about the lattice, the formation of the lattice energy. Right? You can see your second, the Cl2 gas becoming as a 2Cl. This is what is called the atomization. This one. So this is correct. Look at here, Na becoming as a Na solid is becoming as a Na gas. Yes, that is a sublimation. This is also correct. And here, chlorine gas becoming as a chlorine minus. What is that? Yes, that is electron gain energy. That is also correct. Here, ionic state of what? The gaseous state of the ions. It's forming the solid NaCl. So that should be what? The lattice energy. That is also correct. Do we have this one? No, right. We don't have. NaCl equals Cl minus equals. So that means what? This answer is wrong. Did you all understand, guys? Are you all have the clear picture about the Born-Haber cycle? Hopefully, guys, just go through that question. If you have the complication, please ask me tomorrow. I will redo this question. And please, you able to construct. Tomorrow, I will ask such question. Please, in your own, please construct this diagram and show me. Right? Okay, guys, I think so. It will end up. It's almost 9:28. No point of starting again. Okay, guys, you all can leave. Assalamualaikum warahmatullahi wabarakatuh. We will meet you tomorrow. Bye. Take care.
Okay, madam. Bye. Waalaikumsalam.
Thank you, madam.
You're always welcome, guys.